Okay, now we'll go to Chebyshev inequality part 3. Hopefully you listened to the first part and the second part, so we can continue to the third one. This one will just do the same thing, and it will be easy like a pickle if you listen to the first two. We'll take now an example. We start off with a statement. The statement goes like this. X minus 6d cubed is equal to 20. What does this mean? It means, as usual, you have a distribution. You have things that are on the points that can be the weight of people, the height, the amount of rainfall, and let's just for simplicity's sake imagine that there are only a few, cannot be only a few numbers, let's say 40, 45, 50, 55, just to make things simple, not to go with continuous stuff. Discrete stuff that just go by the integers or even by the fives to make it even simpler. And self-understood, it can be 10% of the time, 10% of the people are 45. It can be the age even if you wish. Taking the distribution of the age of a people of a certain town, then you go 20% or 50, 30% or 60, so on till you add all the percents together to 100, and that is what is the distribution is meant. It's a random variable. It means the ages can be 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, and then there's percentages that are associated with each random variable. They must add up to 100%. That is the general run-of-the-mill what distribution means. What do we do now? So we could fool around with it. Math is all about fooling around with numbers. What are we fooling around here? We're saying, let's take the number 60, let's take each x value, let's say x is 45, 45 minus 60, that is 15, cube 15, cube it, 15 cubed is, hold on a second, I need a calculator for that. 15, it's good to have a cube button in the calculator. 15 cubed is 3375. It's a high number. And then multiply that by its probability. So here we said that 45 has, I think I said 40%. So you take this number, you multiply it by 0.45 times 0.45. It's 1518. You got 1518. Just do that to all the numbers. So just go on to 50. First you take 60 minus 50. You take the absolute value, just how far it's off 60. It's 10. 10 cubed is easy. 10 cubed is 1,000. Then you multiply that by the probability associated to it. So it could be 30% or 20%. Just do that with all your random variables. You see how far it is from the number 60. You cube it. Then you multiply it by the probability associated with that random variable. You get probably quite a high number because you're cubing stuff. Cubing jumps very high. But here, I think I'm not gonna change it because it's a tough thing. I just gave the number 20. Maybe I should change it to a higher number. It's almost impossible to get a number 20. I'll change it for 100. 100. I want to make something that at least makes sense halfway. It's very hard to get it. By cubing stuff, you'll jump very fast. Or maybe even 100 is too little. Yeah. Even 100 is too little. I'll make it into 1,000. I'll make it into 1,000. It's a simple number. I'll make it to 1,000. You'll see soon why. Because you're dealing here that if you just move a drop this way and a drop that way, and you cube it, you just get high numbers. So I want to make a thing that's sensible, and if it's a low number, then everything must be very close to 60, and that's what this whole tape is about. What is it about? Precisely what I'm worried now, and that's why this is so intuitive, because I'm trying to do things together. You should get a feel what this is all about. This is about telling you that since I am giving you a limit, 1,000 is a very small number when you're talking about cubing stuff. So since I'm giving you this 1,000, as let's assume 1,000 is a tiny number. Yes, if you're busy cubing stuff, then 1,000 is a tiny number. So I'm limiting you to 1,000, so you cannot move away too far from 60. And if you do move too far from 60, you cannot give him only a tiny percent. You should not ruin the whole thing, because he's so strong, this guy that is far away from 60, that he can blow up the whole thing. So we gotta give him a tiny amount, just like you can't put in too much hot pepper in the soup. It ruins the whole soup, it overtakes the flavor. So this guy that's all outside the boundaries, far away, he can only put in a pinch of salt. He'll take over everything. So this is the ideology behind it. Now let's go to the practical point of view. Just as we did the first two tapes. How much? So the question starts off. This is the information given. Information given is we have a certain distribution. Ex minus 60 cubed is 1,000. That is the information giving. If you take the all rounding variables, you should take it the absolute value, how far it's from 60, you cube it, you multiply it by its probability, you are not going to get anything above 1,000. So now somebody will ask you, I'm going to give you a number, and you'll tell me how much can I put in. It's like, I give you the example with the hot pepper. Somebody tells you that, imagine they have a rating for hot pepper, how spicy it is. They have sometimes extra hot, super hot. So somebody has a rating, this has a rating of hotness of 10. I'm going to give you that rating, and you tell me how much I can put into the soup. It's very hot. Don't put in more than one grain of it. If it's not so hot, then put in 5 grains. So I'll give you the hotness, in other words, how far it is from 60. You tell me how much can I put into the soup. I'm going to give you the number will be, again, as I like to use, it will be, right now, it will be 5. Because 5 is already quite bad. So my question will be like this. I want to know how much percent can be 5 units away from 60. Yes, how much is the most I can afford to have 5 units away from 60? Let's think. If we have 5 units away from 60, so that's 5 cubed. 5 cubed, let's say we have 65 or 55, that's 5 units away from 60. From this spicy stuff that's 5 units away from 60, we get 5 cubed is 125. 125 times what is 1000? 125 times 1000 over 125 is equal to 1000. Sorry. Yes. Okay. So again, we are having here, we were asking how much can it be, how much of this can be, so here we have no problem. It's actually, we see that 5, no problem whatsoever. If we have 5, it's 125, so nothing wrong with that. We can have everything and we'll still have less than 1000. So I'm not going to use 5. I have to change my mind. We'll use 10. Even 10 we have no problem. I did a good job. Let's use 15. I'll use 15. That makes sense. The question will be, I want to know how much can be 15 units away from 60. It means 45 or 75. That's 15 below or 15 above. How much of the distribution can lie in that area that's 15 right side or left side? So let's see if we have a high percent of that. So 15, first of all, 15 cubed gives us a high number. 15 cubed gives us 3375. So we must minimize this. 15 cubed times x is equal to 1000. Fifteen cubed times x equal to 1000. What percentage of 15 cubed can we afford? So that is x is equal to 1000 over 15 cubed. Do with a calculator. 1000 divided by 15 cubed. 1000 divided by 15 cubed is 29%. We cannot afford more than 29% of our distribution to be in that radical area, in the area that's 15 units away from 60. If we would have that, then we would blow up to a number that's higher than 1000. This is the same idea, and so what do we gather from all of this talk? That general equation. If you're given information in a format of this one here, x minus 60 cubed is equal to 1000, and then you ask yourself, how about having stuff in the radical zone, like less than 45 or above 75? That's 15 units away. So you answer to yourself, hello, 15 cubed is a certain number. It cannot if 15 cubed is above 1,000, so you cannot have, as you look at the bottom, 15 cubed times x is equal to 1,000, so x must be less than 1,000 over 15 cubed. Obviously the question only makes sense, as we just figured out now while talking, if you're talking about a zone that when you cube it you're getting a number above 1,000, because then you start running into trouble. If not, you have no trouble. So the only question when we want to answer what is the most percent you can give to him, as if you're stingy to give him too much, is only if you're talking about something that's spicy. If it's not, you can add as much potatoes you want in the soup, it's not going to ruin the soup. It's only if you're talking about something that's spicy. So how do you define if it's spicy? If that number is far enough that if you cube that, it will be higher than the number of the final thing. Then you have to minimize them to a certain percent, in this case 29%. So general rule, let's finalize this, as mathematicians like to formalize stuff in a very fancy language, and that's, we'll close this whole discussion with this. And it's written like this: E, I'll show it on the screen soon, x minus b m is equal to k if this is true. I'll show you what I wrote meanwhile. If e x minus b to the mth power is equal to k. And I'm telling you a fact that this distribution has this property: x minus b, let be any number, I don't care, it could be 50, 60, 70. M is a power, it can be the third power, fourth power, fifth power, whatever it is. I'm telling you certain facts. I'm telling you that this, if you do this, it will be k. K is the number, and that we just said is 1,000. It can be any number. This is the fact that I'm giving to you. Now the question is asked: what is the probability? How much of this distribution can be then probability that x minus b is greater than a certain number. Let's call that number j. Then probability that x minus b is greater than j. Here in j is 15. It means how much, this is a fancy way of asking how much of the distribution can be 10 units away from b. B is 60. Again, don't get misled by this fancy gibberish here, or jargon. It's simply saying how much of this distribution can be away from 60 by 15 units, or how much can be 45 and below, or 75 and above. What's the maximum that can go in that area? how much? Answer is it's equal to the maximum that can go there is equal to you take this number k and you divide it by j cubed, or j to the mth power. It's k over j to the mth power. K in this is, in the first case we had k is 1,000 and j was 15 to the third power. That's the most you can go. The reason behind this is very simple, because j to the mth power that is the j is the number if you're going to the extreme number like 15, 16, how far you want to fly away. You cube that or you quadruple that times x is equal to k. Let me write it down. J to the m times x is equal to k. So x is equal to k over jm. J to the mth power times x. X will be how much percent? You take this radical number, you blow it up by the mth power, and you get k. K is the number that the expected that number, the e. So x must be k over jm. You cannot go higher than that. If you go higher than that, you can give more percent and forget about getting k. You'll get something higher than k. So it's like telling us, if we tell you that e x minus b to the mth power is nothing more than k, it's only k, then beware, do not give j a very high percent, because if you will, then j to the mth power times something will be greater than k. So we must be cautious not to allow this j, this monster, to give him a nice amount of distribution. The most we can give him is k over j to the m. Like this, make j to the m times k over j to the m is equal to k, and we are still in at least theoretical possible to get this low number, quote unquote, of k. I hope you enjoyed this video, and I hope I tried to make it very simple. And please use, I hate to use ABCs, I love to use numbers. Make yourself a number, just as I did with 1,000 and 15 and 60. Just make a number and think about what you can do with it, how far you can stretch out this radical number, how much percent you can give it. Do not work with ABCs. ABCs are meant to confuse you. The textbooks do it to confuse you. If you use numbers, get it to your brain, and the ABCs are just here to show off. Thank you for listening.